Hey, and welcome back to Gaffy's Grinds. In this video, we're going to continue our Back to Basics series on titrations by working our way through the ordinary level exam questions. This is the ordinary level exam question from 2016. It was question 2. So grab your exam papers and work along. Grab yourselves a periodic table, a calculator, and a piece of paper to work on. Okay, so this is question 2. It's actually quite a tricky question for ordinary level question. I'll explain why as we go through. What I would like to do is I would like you to pause the video, read this piece of text from there to there, and underline anything you think is important. All right, so what we're going to do is we're going to jump into the questions. We'll come back to that text later on. Okay, and we are going to look at question 2, and it's part A. So part A says, explain the underlined term. So they're talking about somewhere above here, and I see it's here. Explain the term endpoint. And this is actually quite a tricky thing to explain for, especially for at ordinary level, endpoint. Now there's a couple of acceptable answers, but what I'd like you to do is I would like you to pause the video and write down what you think is meant by the endpoint in a titration. Pause the video. Okay, so let's have a look at the possible answers here, and I'll tell you which one is my favorite. Okay, so this is part A. Okay, and I'm just going to ask you to pause the video and read the possible answers. Remember, this line separates acceptable answers. So this is the first acceptable answer, then this one is the second, this one is the third, this one is the fourth, and so on. Okay, so pause the video and read through the possible answers and compare them to your own answer. Please do that now. Okay, so we know that a titration reaction is all about reacting two chemicals together in very accurate quantities. So how do we know when the reaction is over? Well, my favorite titration here, or my favorite answer here is this last one, number 4. It's where equal numbers of moles of the hydrochloric acid and the sodium hydroxide solution have reacted with each other. In my view, that's exactly what a titration is. You've got an exact amount of moles of the base in the conical flask, and you want to add the acid until you've added the exact amount of moles that the reaction is just exactly finished. So that's why this one is my favorite. I think that best explains what a titration is and when it's over. So when you've got exactly the same amount of moles of one chemical, one reactant as you do of the other reactant. Looking through the other answers, you can see as well the base is just used up. So you've added the acid until all the bases reacted and there's none left. So base just used up. It's also, you could say, well, it's when the color change happens, when the indicator changes from one color to the other. Well, that's what happened. That's what tells us it's the endpoint. So they can't really argue with that definition. And then I think the first answer is quite like the last one. Sufficient acid or just enough acid has been added to exactly react with the base, which is in the conical flask. Either way, you've got to have said one of those things, all right? So check in your answer, did you? And if you did not, then make a note of, I would think that this is the best one, the bottom one. That's my favorite one. All right, let's go back to the questions now. Give yourselves a mark. That was worth 5 marks. All right, B, name a suitable indicator for this titration here. This exact same reaction as our previous year, or sorry, the previous question, which was 2018. This is 2017. It's the exact same question. Oh no, sorry, this is 2016. It's the exact same question as the last one. Pause the video and do this now. All right, then we can name either indicator, okay, because it's a strong acid, strong base titration. We can use either of the indicators, either methyl orange or phenolphthalein. So see here, methyl orange, phenolphthalein. Forget about methyl red. We never discussed that one really in Leaving Cert Chemistry. Methyl orange and phenolphthalein. That's your correct answer there. And that was what 6 marks. Easy. Right, C, describe the procedure for rinsing A for the titration. So rinsing A, which is here. So this is C. 1, describe the procedure for rinsing it. And then 2, name a piece of glassware B used to measure out exactly 25 centimeters cubed of the sodium hydroxide. So in other words, just name that. So name B and talk about how you rinsed A. Okay, now be as specific as you can about A, everything that you can about how it was rinsed. Or sorry, how it was rinsed. Pause the video and do that now. All right, so C, how do we rinse it? Okay, so as you can see, it's a burette. So it's first rinse with deionized water, so that'll get you 3 marks. But then this double line means you have to also have the next answer. It's rinse with the solution it will contain, or you could have said it's rinse with hydrochloric acid. You have to have both rinse with deionized water, and you have to say rinse with the solution it will contain, or rinse with the acid. All right, that's get you 6 marks. And then the name of the second piece of equipment was a pipette. So worth 9 marks, that bit of the question. It was pretty nice. Part C worth 9 marks. All right, moving on. Calculate the concentration of the sodium hydroxide solution in moles per liter. Okay, so we're straight into our calculation, part D. Okay, so part D, calculate the concentration of sodium hydroxide in moles per liter. So I'm just going to show you the information that you're going to need again, because you'll need the information at the top here. Pause the video and work out your concentration in moles per liter. Okay, so to do this, what answer should you have got? First of all, I will tell you what you should have got. In moles per liter, it's 0.09 molar or moles per liter. So well done if you got that right. And then the second bit is to calculate the concentration in grams per liter. So this is part 1 and this is part 2 in grams per liter. Pause the video and work out your concentration in grams per liter. Okay, you should only be watching if you've done that now. Your answer here should have been 3.6 grams per liter. Okay, so well done if you got those right. If you didn't, we're going to work our way through this together now. Okay, so the first thing we should do is write down the two reactants. It's HCl plus NaOH. Then what we want to do is we want to use arrows to show our concentration and our volume in liters used in each titration for each of these. So from the pieces of text or the piece of information up here, let's pick out our information. So I'm seeing here, I'm seeing that it's 0.1 molar hydrochloric acid, and on average we use 22.5 centimeters cubed. So I need those pieces of information here and here, but I need my volume used in liters, not in centimeters cubed. Okay, so hopefully what we said here. No, why is this not working? Sorry, I'm trying to just erase those brackets and it's not working for me. And as my screen is also frozen. Give me 1 second. Oh, I think we might be in business now. Yeah. So it was 0.1 molar and the concentration was 22.5 centimeters cubed, which is 0.0225 liters. Okay, for the NaOH then, well, we're obviously trying to find its molarity. Look what it says, calculate the concentration of sodium hydroxide. So it's a question mark molarity. And what volume did we use? It was 25 centimeter cube portions in the conical, which is 0.025 liters. All right, so planning out our calculation here, we don't need the information in the text anymore. We've got everything we need here. Planning out, what do? We're going from moles of HCl per liter. We didn't use a full liter per titration, so we want to find out how many moles we used in a titration. So it was a lot less volume. So we're going from moles of HCl per liter just to moles of HCl. That's how much we used in a titration. Then we're going to moles of NaOH. And then we're going to find out what was the concentration. So moles of NaOH per liter. All right, so now I've helped you plan it out. You have another opportunity to pause the video and you take over. All right, so you should only be watching if you've had a genuine go at this, and a reminder what you're looking for is 0.09 molar. All right, so we're starting with 0.1 moles NaOH per liter. Okay, and of course I want to go to moles of NaOH, so I need my liters to cancel here. So I'm going to need to times by a number of liters. So times this by a number of liters that we used in each titration, which was this. We used this much HCl, so 0.0225. Okay, that's obviously going to allow me to cancel liters because it's liters over liters gives me 1 and cancels out, in other words. And that gives me 0.1 times by 0.0225, and that gives me 2.25. 2.25 times 10 to the minus 3 moles of NaOH. No, sorry, I was wrong here. Apologies. This, of course, is HCl. The HCl is 0.1 molar. So this here has to be HCl. All right, so that has got me to here. The next thing I want to find out is how many moles of sodium hydroxide did this react with. So I'm going to the next line to do the next bit. I'm rewriting this out. I have 2.25 by 10 to the minus 3 moles of HCl. And I want to find out how many moles of NaOH reacted with that. So that means I need this to cancel. I don't want moles of HCl anymore in my answer. So to get that to cancel, I'm going to put that in the base of the conversion factor. So moles of HCl goes down here like this. I'm going to cancel that out. And that means I want moles of NaOH in my numerator. Go up to my reaction here, and I see that it's 1 mole of HCl for every 1 mole of NaOH. So it's 1 to 1 is the ratio here. And that gives me the same number again, 2.25 times 10 to the minus 3. But now it's not moles of HCl anymore. Moles of HCl, it's now moles of NaOH. All right, I'm nearly there. I've got moles of NaOH. I've calculated this, and I need to now find out what was the molarity of that. This is the amount of moles per titration, but this wasn't in 1 liter. This was in a different amount of liters. So I'm going to put liters in the denominator and write down how many liters I was using. So it was 0.025. So 0.025 liters. That gives me 0.09 molar. And of course, this is NaOH. All right. So that is the part 1 done. That's part 1 done. And the second part asks you to find the concentration in grams per liter. Okay, so how do we take that number and go to grams per liter? So I'm going to rewrite this out. Of course, I'm going from moles per liter to grams per liter. That's what I need to do. So I'm going from this here, 0.09 moles of NaOH per liter. And I want my answer, so I'm leaving space here for a conversion factor equals, I want my answer to be in grams of NaOH per liter. Okay, so of course, I'm looking here, I'm seeing liters in the denominator here and liters in the denominator here, so they're the same, so they're okay. But what I need to change is I need to cancel out moles of NaOH. Okay, so to do that, I'm going to set up my conversion factor with moles of NaOH down here in the denominator. So moles of NaOH over moles of NaOH can cancel. And then that means I can put grams of NaOH up here. And looking at the units I'm left with, I've got grams of NaOH divided by liters. Grams of NaOH divided by liters. So I know I'm doing this right. Next thing is, what's the relationship between grams of NaOH and moles of NaOH? Well, for 1 mole of NaOH, there are 40 grams. 23 for the sodium, 16 for the oxygen, and 1 for the hydrogen. Add them all up, you get 40. 40 grams per mole. Molar mass is a basic skill that all of us should have by now. So 0.09 times by 40 over 1. And that gives me 3.6 grams of NaOH per liter. All right, so well done if you got those right. We're back over here now, and there's a little bit more to this question. Okay, and this is something that might not be familiar to higher level students because this titration isn't on the higher level course, it's only on the ordinary level course. But we have seen a question on this before. It says, describe with the aid of a label diagram how to obtain a pure, dry sample of the sodium chloride salt. So we know that when the reaction is over in the conical flask, we've mixed together the acid and the base, and we've turned them into, look what we've turned them into, salt plus water. So how would we then get a pure dry sample of the salt? So pause your video and talk about how we would get a pure dry sample of the salt. And you have to use a diagram. It says describe with the aid of a diagram. So you have to use a diagram. Okay, and I need to remind you of one more thing. If it's going to be a pure sample of the salt, it can't have any indicator in it. So how do we do this to get the salt with no indicator at the end? Pause the video and describe your procedure now. Okay, so let's go and check what they were looking for in our answer here. Sorry. Okay, so here describe, it says repeat, omitting the indicator. So we figured out that we want to add this much acid to this much base and do this without the indicator. So you need to mention that, okay? So repeat without the indicator. So do the titration again with no methyl orange. Add exactly the right amount of acid, which was 22.5, to exactly the right amount of base, which was 25. And then in a conical flask, it said, okay, so you can heat, we basically need to heat the solution, and it's letting you do it in any piece of equipment. Look, you can do it in a conical flask, or you can do it in a beaker, evaporating basin, or evaporating dish. You have to heat to try, or else leave it to evaporate water over time until the crystals form to dryness, dry them out until the crystals form. Basically, what I would do here is in my diagram, I would have, I would think it's best to do this in a dish called an evaporating dish. Evaporating dish. And in here, we're putting acid. Oh, sorry. Well, it's not acid, is it? It's salt plus water. The content, salt plus water with no indicator. We don't want it to be colored. Otherwise, it's not going to be pure salt. So we need to make a bullet point, repeat without the indicator. Repeat without the indicator. So this should be in your description. Hopefully we mentioned this. Repeat without the indicator. And then we want to heat. So you can use a Bunsen. This is a Bunsen. And then evaporate until dry. Until dry. So heat off all the water and leave behind the salt. All right, so something like that. Again, checking your key points, what you have to have. You have to have 3 of these points. That's what it says. Any 3 times 3 here get you the marks. And it's saying allow marks for good label diagrams. Also, deduct 3 marks if there's no diagram used at all. Okay, so there's 9 marks going here. You had to have some kind of a diagram. And you're losing marks if you don't have any diagram. Okay. A sample of the salt was held in the center of a Bunsen flame. What color was observed? Oh, interesting. They're linking in the titration with the flame test. Okay. So first of all, what is the metal present in the salt? Think about that. And then what is the color if you heated that salt in the Bunsen? Very interesting. Okay. Of course, this is sodium chloride. All right. So for F, what color change for sodium? Sodium equals, write down your answer. Okay, should have been orange, an orange flame / yellow flame. It's bright orange flame. All right, guys, that is the 2017 question. I'm sure we're getting sick of seeing these ordinary level questions now because they're getting very repetitive. But even this one had a few little extra bits in that are interesting and that could trick you up. So that's it, guys. I'll see you in the next video.